In this video, we'll do a quick demonstration of the process of unit conversion. Although this is a very, very important skill for us, you'll have an entire lab period dedicated just to this skill. And I'm going to use an example that we're all familiar with. We already know how to do this. That's what's wonderful about this. I love that we don't have to really learn anything necessarily, but we're going to formalize the process. So example, if I say how many seconds in 3.2 years? The heck? But you know how to do this. I mean, of course, yes, go to Google, type in how many seconds in 3.2 years. But that aside, we can actually figure this out using a systematic method called dimensional analysis. And we're going to use what are called conversion factors. Here. These are equalities, which we're going to set up as fractions. For example, we may not know offhand how many seconds are in 1 year. If we did, this would be a very quick step. But maybe we don't. Maybe we know that 60 seconds, which should be S, is 1 minute. That's a conversion factor. We know that. And unit conversion, or dimensional analysis, is merely the combination of multiple conversion factors to get us from whatever units we have, in this case we have years, we know the number of years, to the units that we want, in this case seconds. So we want to think, okay, what conversion factors do we know? By and large, a lot of the conversion factors we will use will be metric prefixes, so how many meters in a kilometer, but that's not necessary here. So, we now know seconds to minutes. Do we know minutes to years directly? Probably not. But we know we can go closer to years, right? We know that 60 minutes is 1 hour. And we know that 24 hours is 1 day. And we'll assume all of these are regular. Or we could be smart. We could say 365.25 days is 1 year. Why not? We can say that. To account for leap years, right? You can leave that 0.25 off. Just an example. So we'll go ahead and leave it on because we're fun. And so now we can say, well, now I know how to get from years to seconds. I just have to go through all these intermediate units. And those units are days, hours, and minutes. Those are our intermediate steps here. And these are all factors we know, right? Sometimes we may not know all the factors. Sometimes we may have to find them somewhere. We may have to experimentally determine them. Or they may be more complex factors, but we'll leave that for another day. Right now, let's work on this one. So, if we wanted to arrange this so that we converted the years into seconds, we always want to start with the one we do know. We know 3.2 years. And how unit conversion works is we take advantage of the fact that a unit divided by itself cancels out. So if we don't want years in our final answer, and years is in the numerator, dare we say, it's our measurement, we're going to want to put years in the denominator so that they cancel out. Year divided by year is nothing. If we had year times year, that would be year squared, right? For calculate an area, it's a base times height, right? So 2 meters, a meter here, a meter here. Meter times meters is square meters. That's how units work. You can multiply them or you can divide them. If you multiply them, you get exponents. If you divide them, they cancel out. And so we want to insert our conversion factor here. Well, we know, okay, well, we'd have 1 year is equal to 365.25 days. And in doing so, years will cancel out. Doing this, if we stopped here and did the calculation, we would see how many days are in 3.2 years. and we would have that number available to us. But that's not what we're interested in. We're not interested in days. We want seconds. So we got to keep going. Notice, by the way, that I've kept the numbers together. That 365 was days and 1 year. That goes on the bottom. So we keep the number on our conversion factor with the unit it corresponds with. And we can flip these conversion factors over. Say I had days and I wanted years. Then I would put days on the bottom, 365 days, and 1 year on top. So these are very versatile. I'm going to just get rid of that line so we can keep on going here. And if we keep on going, we're going to just keep canceling out the units we don't want and replacing them with units that get us closer to our desired unit. So we know that 1 day is 24 hours. And 1 hour, is it H or HR? I don't even remember. Let's say HR. Is 60 minutes. And I've run out of room. But suffice it to say, we can also multiply by 60 seconds over 1 minute. And in doing so with all of this, we will have canceled out the days, canceled out the hours, and canceled out the minutes. We are left with the unit of seconds. And all we need to do then is bust out our calculator and multiply across, or divide as necessary. Thankfully, with all of these, we have 1 on the bottom, so we don't even have to worry about it. So 3.2 times 365.25 times 24 times 60 times 60. And we get 1,009,84320 seconds. Some crazy large number. Lots of numbers there, right? That's something we'll deal with in another video. But for right now, we'll leave the number as is. So we see we get quite a few seconds out, and that makes sense, right? We should always evaluate our answers at the end of a problem and ask ourselves, does this make sense? Would we expect there to be, 100 million seconds in 3 years? Could be plausible, right? Doesn't seem unreasonable. If we got 200 seconds, that's a problem. Even if we got, 20,000 seconds, that's still way too low. So, always a good idea to kind of make sure your answer makes sense for any problem. And you'll do well as a result. So, in summary, we use conversion factors here to cancel out units we don't want and use units that get us closer to whatever we are looking for. And this is a skill we're going to be using consistently throughout the course. And again, it is one you will have an entire lab period dedicated towards practicing.